The topic for today's physics video is impulse. In order to explain this concept, we're going to look at an example of two identical objects falling side by side. Suppose that two identical people step off of a platform that is 1 meter above the ground. It might look like this. From a previous physics video, we know how to determine how fast they will be traveling when they reach the ground and how much time this will take. If our two people both step off of the platform, they will have an original or initial velocity of 0 meters per second. After falling a distance of 1 meter, you should be able to verify, using the equations for free fall motion, that it takes 0.45 seconds to fall. You should also verify that after 0.45 seconds have gone by, the people will both be traveling at a speed of 4.4 meters per second. Now, let's see what happens while they are in contact with the floor. Up to this point, everything has been the same for both people. Person A will just contact the floor, keeping his legs straight, and very quickly come to rest. Person B, on the other hand, will allow his legs to bend. This will allow him to increase the amount of time it takes for his entire body to come to rest. Let's watch in slow motion to see how this happens. Now that both people have come to rest, let's see if we can determine the amount of acceleration for each person while the ground is stopping their downward motion. Applying the definition of acceleration for person A, we find that he will have a change in velocity of 4.4 meters per second during a time of 0.1 seconds. This gives person A an acceleration of 44 meters per second squared while in contact with the ground. If person A has a mass of 50 kilograms, the net force experienced will be 2,200 newtons. For person B, the change in velocity is the same as for person A. However, because it took a longer time to come to rest, the acceleration is much smaller. Person B ends up with an acceleration of 14.7 meters per second squared and a net force of 735 newtons. Let's look at our results more closely. Person A had 3 times as much force as person B, and it took person A 1/3 the time it took person B to come to rest. This suggests an inverse relationship between force and time. We start with F equals mass times acceleration. Now, we'll replace acceleration with this definition, the change in velocity over time. Now let's rearrange things a little bit. We can multiply both sides of the equation by delta t. Remembering that delta means change, we can distribute the mass to arrive at this result. The right-hand side of our equation shows how the quantity mass times velocity is changing. We call this momentum. So, momentum is defined as the product of mass and velocity. Because velocity is a vector, so is momentum. Because momentum involves mass, it would not be a good idea to also use the symbol m for momentum. So, instead we use the letter p. Our result is similar to what we found for work. When a force acts, something changes. With work we said the result was to change the energy of an object. In this case, it is not energy, but momentum that is changing. So, we'll define the change in momentum to be the impulse. We can calculate impulse by either multiplying the force and the amount of time during which it acted, or by calculating the change in momentum. If the momentum change, or impulse, is constant, then by altering the time over which the force acts, we can change the amount of force required. This brings us back to our original example. Person A took a small amount of time to land on the floor and had a large force. However, person B took much longer to land and therefore experienced a much smaller force. To end this video, we're going to watch a short scene captured by the Insurance Institute for Highway Safety, as you watch a 1959 Chevy Bel Air collide with a 2009 Chevy Malibu. Think about the advantages of airbags in a collision and how they're related to the topic of this video.